let's talk about dividing polynomials. In this video, I'm going to take us through just one example, and it's going to be a long division style of dividing polynomials. So let's talk about this one. So in this one, my dividend is a fourth degree polynomial because the highest exponent is a 4, and my divisor is a linear or a first degree polynomial, again, because that highest exponent is a 1. So we're going to do this just like you would if you were dividing whole numbers. So maybe I've got, for example, something like 379, and I'm going to divide that by maybe 5. What I'm going to do is put that first one, my dividend, inside the division setup. So I've got 379 here, and then that 5 drops to the outside. So then the question that I'm asking is, what do I multiply this 5 by, my divisor? What do I multiply that by to get 3, or at least to get some multiple that's below 3? And 5 is bigger than 3, so I'm not going to be able to multiply anything to get there. So then we look at 37. 5 times what number gets me close to 37? And that would be the number 7. So once you've decided what your number is, we're going to multiply down, write that number beneath, and then subtract. And we're subtracting the entire 35, not just part of it. We want to subtract the whole thing, and that's going to be something important when we talk about the polynomials in a second. So when you subtract, we get 2, drop your 9, and then you just repeat the process all over again. So this is what we're going to be doing, but with polynomials instead. So let me clear all this, and then we'll set it up. Okay, so my very first step is to figure out what do I multiply the divisor by to get that first term of my dividend. But we're going to just focus on the first term of your divisor and how we multiply that to get the first term of the dividend. So I've got 2x, and I want to multiply by something to get 2x to the 4th. All I'm missing, since that coefficient's already the same, is the x to the 3rd. And I can line it up here above my x to the 3rd, or really put it anywhere. It doesn't matter. Once I've decided, I multiply down, and since we're dealing with polynomials, we need to make sure we multiply the whole binomial here. So I'm going to distribute that x to the 3rd to the 2x, giving me 2x to the 4th, and to the positive 3, giving me positive 3x to the 3rd. And then, just like we did on the last one, I subtract. But we need to subtract everything. So that negative is actually going to get distributed to the 2 and to the 3. So let me go ahead and do that. I'll take my negative and I will subtract the 2 and the 3. Now when I add down 2x to the 4th plus a negative 2x to the 4th, those add to 0, which is what I wanted. 5x to the 3rd minus 3x to the 3rd gives me 2x to the 3rd, and then I bring down my plus 7x squared. And then I just repeat the process. So now the question is, what do I multiply my 2x by to get that 2x to the 3rd? Well, I have the 2, I have the coefficient already. I'm just missing 2 of the x's. So let me multiply by an x squared to get me from 2x to 2x to the 3rd. I now take that x squared and I distribute down. When I multiply, I get 2x to the 3rd plus 3x squared, and I subtract everything in that row. So I distribute my negative to both pieces and then add down. 2x to the 3rds cancel. 7 minus 3 gives me 4x squared, and then I bring down my next term. And I repeat the process. 2x, I need to multiply by something to get 4x to the 4th. So looking at the coefficients, 2 times 2 gives me 4, so I know I need a coefficient of 2. And for my variables, x times x gives me x squared. So I need to multiply by a 2x. Then I take this and distribute down. 2x times 2x is 4x squared, and 2x times 3 is 6x. Then I distribute my negative to subtract everything, and I've got 10x, and I bring down the 15. My last step is to decide what do I multiply 2x by to get 10x. Since I have all the variables I need, I just need to multiply by a positive 5. I take that positive 5, distribute down to get 10x plus 15, which is perfect because when I subtract, the 10x's cancel and the 15's cancel, leaving me with a remainder of 0, which means this divides perfectly and our 2x plus 3 is actually a factor of our original polynomial. So then our quotient, or our final answer, is this x to the third plus x squared plus 2x plus 5 with no remainder. A couple of things we'll talk about in later videos is what happens when you have a remainder, what happens if not all of your powers are represented. So for example, in this one, we've got an x to the fourth, then we drop to an x to the third, x squared, x to the first, and then we have our constant term with no x's. So starting at the highest and going all the way down to the lowest, all of those powers are represented. We're not missing any. And that is super helpful because when we went through and we were doing our subtraction, all of our terms were like terms. We never had any that had different exponents that we were trying to add together. So the fact that we had every exponent represented was the reason that everything worked out so nicely. And then the other thing we'll talk about is what happens when your remainder is not 0 and things don't divide perfectly. But for this video, that should be enough to get you started. Hope that helped. Thanks for watching, and I will see you next time.